Morning, I'm Steve Werby, and this is Randy Todd. In the description for our presentation, it said that I work for the University of Texas San Antonio. I did at the time we submitted the presentation. I'm now an independent consultant. Randy still works for UTSA. Just to give you a little bit about my background, for the last 6 years I've been a Chief Information Security Officer at 3 different organizations. Before that, my roles were hands-on technical.
I have a pretty extensive web development background. I joined security a little over 3 years ago, so I'm enjoying being in security.
And we have a small group here today. Feel free to ask questions or contribute to the discussion. We want to hear about your experience with password cracking and other topics we're going to discuss. Feel free to ask questions during the presentation. We'll also allow for some time at the end. There's a few things we're hoping you're going to take away from this presentation. We're going to be talking about Amazon's Elastic Computing Cloud service and talk to you about what value it can provide to you. We're going to discuss some methodologies for cracking passwords. We're going to give you some thought about different options in terms of building hardware and systems, leasing it, or buying systems, and when those types of decisions need to be made. And we're going to talk a little bit about the difference between passwords and passphrases, and how you can use dumps that are publicly available to benefit your organization's security. We're going to be looking at some password dumps, by the way, that involve record sets that are in the hundreds of thousands and millions of records. Does anyone here actually work for an organization that has a user base that's that big? Okay, so more than 1 million users? Okay. What about the rest of you? How big are your organizations in terms of user base? Okay, well, that gives us a good idea. This is the agenda we're going to go through. Who doesn't know what hashes are? Does everyone know what a hash is? Okay. We won't spend any time talking about this. The password breaches that we're going to be talking about all involved unsalted hashes, which are much easier to crack. And there's a number of hashing algorithms that are used by various organizations like MD5 and SHA-1. If any of you have any questions about those, we can talk about them. But in general, they're not very strong. Okay.
These are some of the leaks that we analyzed. I think we're going to be mainly looking at eHarmony, but we do want to point out, and I think I'd talk about this later, but a lot of times you can use previous leaks or passwords that you've cracked from previous leaks in dictionary files for cracking leaks that come later on. As you can see, these are all unsalted. eHarmony had the MD5, LinkedIn, SHA-1. And we used RockU also as a dictionary. It was a very extensive leak. It's the largest one.
Yeah, let's not stand.
You can do online or offline cracking. And then the tool that we used is Hashcat, which provides for dictionary attacks, brute force, pre-computation. They also have permutation as well. When you we'll talk a little bit more later, but when you use, you can use Hashcat Plus, which has the CUDA support, so that there's some other options that you get with that.
Yeah, the big focus here is that we're only doing offline cracking, so we're looking at hash files. We're not performing any attacks against systems directly. In terms of the speed of these various types of attacks, the slowest methodology is going to be using the CPU, your processor within a computer or server. A GPU, the graphical processing unit, is optimized for the kind of calculations that are done in password attacks, and so it's much faster. A rainbow table, which is a pre-computation, essentially a plaintext file, a plaintext string with its hashed output and a lookup is performed, is much faster than any of these options. However, it becomes computationally infeasible based on the storage if the key space is extremely large or if salting is used. So we're not going to focus at all on rainbow tables today. There's lots of information on the internet about rainbow tables. So why should you care about this? Obviously, it's interesting and fun to look at a password leak that's available on the internet and see how many passwords you can crack. But that really doesn't benefit your organization a whole much. But there is some benefit, and Randy will talk about that. But internally, you can use these types of processes to perform attacks against your own systems to be proactive in terms of the security, so you can determine whether the passwords in use in your organizations are strong, or if you believe a system's been compromised, you can determine whether it's important to notify internal users that they need to change their passwords. You may have a situation as well where somebody's left your organization, and when they do, so if somebody leaves your organization, you need to gain access to their account, what are you going to do typically? So somebody reports to you and they've left your organization, you need to gain access to their account, what would you typically do? Does anyone have any thoughts on that?
Reset their password.
You'd reset their password. But let's say that you believe they use the same password on a third-party site that you don't have access to. You could crack the hash of their password, which internally you wouldn't really care about because you could reset the password, but now you would be able to acquire the password that they may use an external site like Facebook or Twitter or Salesforce.com or somewhere else where you actually need to gain access. So that's one reason you might do that. It's also good to be able to strengthen your arguments when you're talking to others. There's a lot of folks, potentially CIOs or people that are not as technical, that believe it's extremely difficult to crack passwords. Using these tools, you can demonstrate to them how easy and time efficient it is to do that, and you can leverage that to be able to pursue things like changing your password policies, moving to different algorithms, for example, from MD5 to bcrypt, or to pursue things like two-factor authentication, which provides an additional layer of authentication control. Yes?
Have you talked to lawyers about the idea of cracking someone's password and then using it to log into their Facebook or Twitter account or something like that?
Well, in my experience, pretty much any time I talk to a lawyer that works at the same company as me, their answer is no for pretty much anything I ask them, no matter what it is. So the trick is to word the question the opposite of the way you would normally ask it, so when they say no, they really mean yes. I think it's really going to come down to, in that case, I've talked to lawyers, it's whether that account belongs to the organization or it actually belongs to the user.
Yeah, we had an instance where someone left my organization now, but and they had an account that was set up to use for our organization, and the people that were there after he left, they contacted us and said, we can't get into this account, we need to get, it's our account. So that's a good example of where the account really belongs to us, it was named according to us.
I find this comes up a lot because it's one of those things as cloud and third-party services explode, organizations are not doing a good job looking at how they're going to maintain access to accounts that their users and employees are using on behalf of their organizations. So I expect this to be more common. I'm not suggesting that what you want to do is crack passwords. The better way would be to escrow the passwords and have some legal protection so you can gain access to those systems when you need to.
And we didn't crack his password and use it or anything, but it just brought up this idea. Okay, this came up with the, do any of y'all remember there was a Yahoo video leak? That I actually got that leak and used it to basically just go through and look for my users. So this is kind of outside of cracking, but I just thought it'd be good to mention that it might be a good idea to kind of keep an eye out for what leaks are out there and go through them and look for your users, because they're obviously compromised. They need to change their passwords. Like Steve said, a lot of times people use the same passwords as they do on other places. So I think it's just a good idea to inform your users of their accounts being exposed. And like Steve kind of talked about internal dumps, you can dump your organization's hashes and do passwords audit on it. And let me get a show of hands really quick. Are any of y'all in higher ed? Okay. Y'all corporate or government? Okay, just corporate? All corporate? Okay. We have some different challenges in higher ed. So, such as changing password policies and having like CIOs that don't understand how easy it is to crack passwords. So, just wanted to get an idea of what our audience is. So what I did is with the Yahoo video, I just went through and I sent an email. And in our organization, we actually have 18. We're part of UT System, and there's actually, I'm not sure exactly what it is, 16 or 17 different universities that are part, or components that are part of the system. So I actually went through and I looked for other components as well, kind of just a good guy thing to do, and I informed all of them as well. And I included, some information about the incident, a very brief explanation of hash cracking and how to create complex passwords. Whether or not to include the password, that's kind of up to you, and it may be against policy to even send it through email or even provide it at all. So just some things to think about is, when you're informing your users. A usage case for cracking passwords is where you want to crack them and see like how complex they are, or what kind of passwords your users in your organization are using. When you're doing this, you want to include the time to crack, and then at the end, and this is another kind of example where you would use the analysis of the cracking that you did to provide to the CIO, as far as what the password makeup is. So you'd want to, and another thing you can do is save the data for future presentations. There's a good password analysis tool called People that we actually did use it, but we didn't include it in here. It's kind of long, but it's a really good analysis tool should you choose to do this. You can also use, like I said, you can save the data for future presentations, internal, external awareness campaigns like Cybersecurity Awareness Month. Do any of y'all do that? No? That doesn't exist in the corporate world? Okay, we do. We try to. And then as well, you can create dictionaries from your previously cracked passwords. Like I said, RockU is a really large one that has been really beneficial as far as being used as a dictionary later on. So to create the dump of your password hashes, you can use a tool like PW dump or FG dump. You just want to make sure that you secure the dump, store it in an encrypted drive behind lock and key, and when it's transmitted, an internal system. Some cracking tools that you could use are Loft Crack. That actually will pull the dump for you. We didn't use that. We used Hashcat, like I said. Some other tools, John the Ripper. How many of y'all have not used John the Ripper? Actually, I have. So. Okay, great. And then CryptoPhase, Multiforcer, I'll let Steve talk about.
Yeah, so the three tools that we really worked with during our research were Hashcat, Hashcat Plus, and Hashcat Lite. Hashcat is designed to run on a CPU. Plus and Lite are designed to run on a GPU. Plus is designed to work with an input file consists of many hashes. Lite is optimized to work with an input file consists of a single hash. So it's much faster, but in most experience, you're going to be running attacks against a multi-hash password file. Who's actually used the Plus and Lite versions that run on a GPU? Okay, so a few of you have. That's great. Has anyone used the CryptoHaze Multiforcer? Okay, good. Yeah, so the CryptoHaze Multiforcer also runs on a GPU and allows you to do distributed password cracking. Yes?
Are you going to go into the performance differences between GPU and CPU?
Mm-hmm. We are. Yeah, great question. Okay. So, you have some options. Randy ran some of these tools on a computer he had which does not have a GPU that can be utilized. You can purchase your own hardware and build your own systems, throw a bunch of GPUs in it, and have the boxes available 24/7, 365. You can build some servers in the cloud using Amazon's EC2 service or other provider services. Can you think of the pros and cons that exist between those different alternatives? Does anyone have anything they want to throw out? Has anyone built their own box that has multiple GPUs in it?
Well, our team has, but the biggest thing we ran into is getting enough power to to supply the cards, and then where do you keep it cool, and how much draw it actually takes. You can watch. So if you have it in a closet in your house, you got a little fan blowing on it, and then your power bill will.
That's a good point. So electrical cost and having electrical infrastructure are important. Yes.
It'll be a lot cheaper to rent GPU time from Amazon.
Okay. You know that from experience, or?
Yeah.
Okay. Some people feel that's not true. We talk to a lot of people who believe that it's a better solution to build your own box. One of the disadvantages to that is, in my opinion, we've already talked about a few, but unless you're going to utilize it on a regular basis, it's not particularly economic. The hardware may break, the hardware may need to be replaced, and you're responsible for all that.
And you void your warranty on some.
Just by doing that.
Does anyone know what this vehicle is? Very good. So it's the world's fastest production car. Wasn't sure if anyone would know what that was. It's a Bugatti. Okay, so here's some of the reasons we talked about. There's also the scalability factor. We're going to talk about different constraints later on in the presentation, but these are some of the factors you run into when you're building your own system. There's also a time component. Most people don't have hardware laying around so that if they have a need to crack passwords, they can just immediately snap their fingers and have a system built, have the electrical infrastructure and the heating and cooling that they need in place to make it work. Never mind the software that needs to be installed. Anyone know what this is? It's the Amazon. Okay, so
Sorry.
it's the Amazon. So it's not the only provider. There's other providers like Rackspace and SoftLayer that you can utilize. Amazon is it's easy to use, and that's what we chose to use for our research. So that's what we're going to talk about. Who in here has set up an Amazon EC2 server instance? Okay, a few of you had. We're just going to quickly walk through what's involved in doing that. Once you have an Amazon account set up, it literally, within 2 minutes, you can have a server stood up that you're able to log into. And setting up an account is really trivial. You essentially need to create an Amazon Web Services account, provide a credit card number, provide a phone number. It then sends you a code. You enter the code in. It verifies your account. And then from there, you can go to the EC2 console and build your server. Okay, and I just mentioned here that in terms of accessing the server, there's some other things that you may want to do, like create a key pair so you can do authentication using a key instead of using a password. And here's what the screens look like in terms of actually building an instance. There's a button in the middle called Launch Instance. You click it, you go to this screen. I've already pre-configured a key pair, so I select it. On the right-hand side here is a list of Amazon machines that you can select from in terms of what operating system and other features you want to have in place. In this particular instance, I chose a version of Ubuntu that was 64-bit, which is one of the systems we set up to do cracking on. The next screen looks like this, and it provides some options to you that you can fill out. I selected a name of Yoda for the server. Chose a specific server type called M1.large, and I'll explain in detail later what that consists of, but it's a system that does not have a GPU. If you're interested, you can specify what zone you want that server to be located in. Amazon has data centers in the United States, Europe, Asia, somewhere else I believe. I can't think of what other location. So you can specify where those are. Now some servers are not available in all areas. And then there's some advanced details, and you can do things there like after the server is automatically built, if you wanted to have it automatically run some scripts, you could actually paste those scripts in, and when the server is built, it will run those. So let's say you wanted to grab some password hashes, you wanted to grab some software, have it untar it and install it, you can paste that all in there, and when it builds the server, it already have run those particular commands. Okay. And then once you get to this screen, the server is being built. If you click over to the console, here's what the console looks like. And this is what it looked like right after I set up the Yoda server. And you can see it's running. You can do some additional things like set up a static IP address. You don't have to. You can see there's a host name here that's automatically assigned. When you start and stop the server, it's likely you will not get the same host name, so it can be advantageous to set up your own static IP, and then if you want to, set up a host name through DNS, but you don't really have to unless you want to. And this is just the bottom half of that same screen, so it shows there's a private IP address, you get a public IP address. Yes?
When you grab those hashes, are you running like an agent on the server you're grabbing them from? Because I see you got the states. Are those states of the actual VMs that you're running there, or the server set up?
Those are the states of the particular servers I had configured for this account. So the different states are started. Well, actually, I don't think that's one. So a server can be stopped, it can be starting, it can be running, or it can be terminated.
So when you go out and grab these password hashes, you just have the user ID and password for the servers, and you run a script to say go out and grab the hashes, or are you having does this install an agent on the server that you're pulling that information across?
It can. In what we're talking about, I haven't done it that way, but using the CryptoHaze tool, you can, which is not the tool we're talking about, it's a better tool for doing distributed password cracking, because you can set up a master server and a bunch of child servers and have the hashes distributed and have it report back into the parent. It is possible to do that this way. I did have startup scripts that installed keys so that I could have transmission of the passwords from one server to another, but you could also do it manually. It's not a lot of work. If I was going to set up 100 nodes to do it, I would definitely automate it. Any other questions about this part of it? You can also set up elastic block storage devices, which are essentially separate hard drives. I did that for the GPU box because I wanted the data to reside on a hard drive, a virtual hard drive that I could reattach to other servers if I needed to. When you set up a server, you get a certain amount, it's like 8 gigabytes of storage space within the actual server itself. And then depending on the version of the server, you get ethereal storage systems, which essentially means that the storage is only available to you while the server is running. So if you stop the server, the data that resides on those storage devices will be gone. So don't make that mistake. Don't do a lot of work. Store it on that mounted hard drive and then stop the server, because you'll lose everything you did. Okay, the pricing system may seem somewhat complex for Amazon, but it's really not that difficult. There's really 3 types of servers. On demand, which is a utility-based pricing model. You pay for what you use. They charge you for each hour. If you go an hour and 1 minute, they charge you for 2 hours. You can get reserved pricing, which allows you to pay for some amount up front and get a discounted rate on an ongoing basis. Then spot pricing allows you to take advantage of excess space that Amazon may potentially have to get a much lower rate. We'll talk about that later on. In terms of the configuration, if you purchase a system that has a slow processor and less RAM, it's going to cost you less money than if you purchase one that's beefier. And so we set up a couple of different servers for testing purposes. Linux costs less than Windows. There's some variance in geographic regions in terms of pricing. And the last 2 bullet points, in terms of password cracking, don't really make a lot of difference. Elastic IP addresses only cost you a few cents per month. Getting advanced metrics doesn't cost you that much, and you're not really transferring a lot of data when you're pulling in password hash files and cracking them, because you're not moving a lot of data around. And you don't need a tremendous amount of storage space. But all the information on pricing is available on the EC2 website. You have anything you want to add on that? This is just a partial screenshot of what some of the pricing looks like. One of the servers we set up, the Yoda server, is using the large instance, which is 32 cents per hour. You can see for Windows it's 46. We were running Ubuntu, so we took advantage of the lower pricing. And we set up a GPU server, which costs $2.10 per hour, based on the on-demand pricing model. If you haven't used EC2, you may want to give it a try. They have a free pricing model. It's kind of like a gateway drug to their paid services. It's free for a year, and I don't work for Amazon. I don't get anything from telling you this. Just curious, anyone here work for Amazon? Okay. And so you can get a free server 750 hours a month on Linux plus 750 hours a month on Windows, and you can get additional EBS storage, and there's a number of other things you can get for free. So you can always try that out. It's not a very beefy virtual server that you get. You can always upgrade it or move to a different pricing model. Okay, so here's what we set up. We set up a server that was running Ubuntu, 7.5 gigs of RAM. It utilized 4 EC2 compute units. Does anyone know what that means? Okay, what we'll explain what that is. Essentially, an EC2 compute unit is sort of a number that tells you on a relative basis how much processing power you get. One EC2 unit is equivalent to a 1.2 gigahertz Opteron processor from 2007. So 4 EC2 compute units is not a very beefy server. The GPU node that we built, there's only one option to select from. It's 33.5 EC2 compute units. You see it has more RAM, it has a bigger hard drive, and it has 8 processors in it. Has 2 NVIDIA Tesla cards, which are fairly expensive video cards, but they don't actually crack passwords any faster than a lower-end NVIDIA card. The service that Amazon has is not really designed for password cracking. It's designed for analyzing data in the oil field, oil industry, or the banking industry, or in the sciences. So for visualization and that kind of thing, that's the kind of processor you want, but we don't have the choice as an Amazon customer to go with something else because that's what they offer. Had they offered something less expensive, it would probably cost less than $2.10 per hour. And any questions about the servers we built?
Actually, how much would that server cost you if you're going to stick it onto your desk, like buy it from Dell or something?
The GPU server?
Yeah.
Haven't priced that out. Does anyone have a guess on what that would cost? It's running 2 quad-core Intel processors. The NVIDIA cards, I think, run about $1,000 a piece. Does that sound right?
That's right.
Yeah, so maybe $5,000. I would say somewhere in that ballpark, plus or minus 1,000.
Thanks.
Mm-hmm. So, I mean, for us, that wasn't really feasible. We didn't have the budget to go build our own machine, nor at the time of our research did we have any kind of need to do 24/7 by 365 password cracking. The last box we set up is one of Randy's laptops. So you want to tell us about your Dell?
This is my secondary laptop. I think we've got these about 3 years ago. So yeah, I had an Intel Core 2 Duo, 2 gigahertz, 2 gigs of RAM. It's an older machine. We just kind of want to point out that you can, if you have to do this, and you have an old machine, kind of use this as an example. Again, it's my secondary laptop.
It's also 32-bit, and other machines we tested were 64-bit, which makes a difference. Okay, so here's the machine.
What was the time difference between? Did you guys compare the?
Oh, we did. Yeah, we did. So we compared all 3 scenarios, and so we'll show you what the results of that are. It's pretty interesting. Actually, when we get close to that, I'll ask what you think the results would be. So Zelda, which was Randy's box, essentially costs $0 per hour. Sure, there's some electrical costs, but it's pretty minor. And Yoda's 32 cents an hour, and Exhibit, which is the GPU box, is $2.10 per hour, using the on-demand service. We'll talk about the spot pricing later, which can drive the cost down, but may or may not work based on what your needs are. You want to talk about this?
Sure. I think I did kind of. These are the options basically available for Hashcat. You can provide dictionary files, which will show kind of some of the ones that we did. Combination attack is basically where it takes your dictionary files and mixes the words around in them, basically. It does take a lot longer to do the combination attack. And then masking, we'll show you an example of that, but basically it's an option for brute forcing where you tell it what characters to look for in what places. And then it has rule-based as well.
Yeah, Randy, how long would the combination attack that you tried to perform on your laptop have taken if you let it finish?
I let it go for 9 days. That's a good question, really. Probably about 3 weeks, I guess. I would guess about 3 weeks.
And all it was doing was taking dictionary words and combining them with each other. It wasn't going to produce a very high number of acquired passwords, and it took a tremendous amount of time on his device. With the rule-based cracking is doing things like shifting characters, substituting characters, and doing that type of thing. Where we got the most benefit was with the masking attacks, which is a more granular brute force attack, and we'll explain what that is.
But I was doing that kind of for fun, so I had all the time in the world.
Okay, so the data set that we primarily used was a 1.5 million record eHarmony password database. It's interesting because if you look at the webpage, it actually says the #1 most trusted online dating site. Apparently it's not the #1 most trusted in terms of protecting and securing your passwords, since they used unsolved MD5s and they were exposed and published on the internet and were very easily grabbed. Here's what the passwords look like. They're just normal MD5s without a salt. Yeah, normal. Yeah, the hashes, not the plain text passwords. And Randy's going to tell you about the Hashcat syntax, which differs a little bit based on which version of Hashcat you're using.
I also want to say that Hashcat actually has a GUI also, which I kind of started out using. But just to talk about, and I think, do we have another slide there where I break down what there? We didn't get that. Okay, I'll just talk about these real quick. So this just launches Hashcat. This is our source file. M0 is just for the algorithms to use, so it's MD5. The output file that you want to send it to, and then we included one dictionary in here. This one's MD5, and then the attack is brute force, so you specify which type of attack you want to use. And then you can specify in the brute force, with the brute force attack, you can specify min and max for the password. And then a remove option, so it removes the hash from the list when it cracks it. This is for the mask. I'm specifying that I only use uppercase characters. I think we'll talk a little bit more about that, but we found that eHarmony only used, they changed all their passwords into uppercase, from lower to uppercase, so it made it a lot easier to crack. And then this is for decimal, the output file again, and then here's our mask. So we're specifying that we want an uppercase character in the first 4 places, and then a decimal. So it'd look for 4 uppercase characters and 4 numbers.
So the options you have lowercase letters, uppercase letters, numbers, special characters, and there are also some foreign language characters, which we didn't utilize. And so this is much more efficient than a normal brute force attack. So if, for example, you know that they don't use, let's say that you assume that people are going to capitalize the first letter of the word, you could specify only uppercase letters in the first position, which reduces the key space. In this particular case, because, as Randy mentioned, eHarmony did something that most people would consider not very intelligent. They actually converted all the lowercase letters to uppercase before they converted them to hashes, which made it a lot easier for us to attack their data set once we discovered that. And in terms of the minimum or maximum, we could have set this to, for example, 5 with a maximum of 8. And it wouldn't work actually for this data set, but let's say you want to do all numeric. You could have it run through all the numeric strings that are 5 characters long, then 6, and 7, then 8. We found it was better to do that separately and store the output in separate output files because it allowed you to back up the hash file beforehand, estimate how long the run would take. Because if a run was going to take like weeks, you might not actually want to complete it, and it allowed you to separate the data out better.
That's a CPU-based version, right? Do you know? Or I'm just asking. That's more like a question. Does incremental? Because the GPU version doesn't. If you do like minimum 5 and maximum 8, it's not going to do that. The GPU version doesn't do incremental. That's
correct, and that's a very good point. On the GPU version, it doesn't actually allow. It doesn't even have those parameters. So if you want to be consistent between the 2 versions, you don't even bother with those, and you just specify what the parameters are here. So that's right. It's in terms of constructing your rule sets on the GPU version, you actually have to put more work into it because it doesn't allow you to specify the minimum and maximum. But you could always put your rules into a text file and write a bash script or whatever your favorite programming language is and have it enumerate those rule sets. Okay. So we're going to kind of move through some of this. In terms of creating dictionaries, there's password files out there that you can use. There's what you would normally consider a dictionary, like your Webster's dictionary. But anything that has strings in it can be used as dictionary input. It could be the Klingon language. It could be movie titles. It could be pretty much anything. Popular locations, first names, last names. And we created a combined dictionary which used dozens of those different types of dictionaries. It did not work as well as using the masking attacks.
Yeah, well, I just wanted to add too, pick dictionary files that are relevant to whatever dump you're looking for. So like eHarmony, the singles.org was a really good one. MySpace, some of the other ones. And you also want to put the more relevant ones at the top of the list. So we'll crack them first and get through.
Good point. This is probably a little hard to see, but this was one of our test cases where we just ran masking attacks. At the very top, we started with all uppercase strings, and what the column shows is the number of strings that were involved in those attacks, the time in seconds it took to complete the attack, the rate, which was the number of strings divided by the time in seconds, the number of cracked passwords, and then a second rate, which was the number of cracked passwords per second. And so as we started to do this, we noticed some things. Well, first of all, we don't show it, but we noticed that lowercase passwords didn't exist. So there was an advantage to us modifying the rest of our rule sets not to include lowercase letters because it would be a waste of time. If we looked at a 6-character string, the fact that they eliminated the lowercase letters, does anyone want to take a guess in terms of how much work that actually saved us? Did it save us half the work, or was it a lot more than that?
32x.
I'm sorry?
About 32x.
That's right. It's a power factor, right? Because for a 1-character string, it's double, quadruple, times 8. So it actually saves you quite a bit by being able to eliminate that part of the key space. We also noticed some of these attacks that we ran cracked 0 passwords. So it's not really clear what the password policy was in place at some time on eHarmony, but apparently you couldn't create a string consisting of all special characters. You could create one of all numeric. And so we were able to modify our attacks based on that. One of the things that you can do is you can start off a masking attack with an individual letter or a string. And so you can use an input file like the RockU password list, which is about 15 million passwords, sort them by frequency, strip off some of the end letters, and see that people do things like create passwords that begin with I love. Right? So you can use that intelligence to create masking attacks. So we created one that used I love, followed by 6 uppercase letters. Took 57 seconds to run, and this was on the Yoda machine, which was the CPU machine, and it cracked 446 passwords, and that was just with 6 uppercase letters following it. If we had changed it to 5 or 7, it would have also found more. Running against 7 would have been orders of magnitude in terms of the amount of time it took. Yes?
So given that your longest run here looks like it was 30 minutes, and that you can buy 30 minutes of CPU time for $1.05, how much do you value your time for optimizing rules like this versus just being done brute forcing and spending a little bit of cash?
And that's really a good point, and I think that really depends on your situation. If I'm working as a consultant and I'm getting paid by the hour, or there's an opportunity cost I could be using my time to get paid, my time's worth a lot of money. It's worth a whole lot more than $2.10 per hour.
I would hope so.
Right? So that's an excellent point, and that's one of the takeaways we want to leave you with is your time is worth something, and so it's not really important in a lot of cases to come up with the most optimal cracking rules, especially if your goal is not to have 100% of the passwords cracked. If you're trying to make the case to a client that their password policy is weak or their hashing algorithm is weak, you don't need to crack 100% of their passwords to prove that. In this case, we ran it for about a little over 2 hours and got 400,000 plus of the 1.5 million passwords. We could have gotten more than a million if we had crafted the rules differently, or we had run it for longer, or if we had run it on the GPU node. Okay. So let's move on. And here's what the results look like. It's an output file. It shows the hashes and the plaintext passwords. Okay, now we get to the fun part, which is the rate. So Zelda was the machine that was Randy's laptop, and we ran consistent tests across these 3 machines. Zelda cracked 14,000 passwords per second. And this was using MD5 hashes that we were testing, the same 1.5 million record data set.
Yeah, it wasn't cracking at that. It was cracking trying.
It was processing password attempts at that rate. It doesn't actually mean, Randy's right, it doesn't actually mean it acquired 14,000 passwords per second. Yoda, which was the CPU box that cost us 32 cents per hour, cracked 6 million per second, and Exhibit was cracking 1.6 billion. That was the GPU machine. So you can see Exhibit, the GPU machine, cracked at a rate of 114,000 times of what Randy's laptop did, and 258 times what the CPU machine did. So the real important number, I think, is the 258, because it cost about 6 times as much as this Amazon CPU machine to run the GPU machine, but we were able to crack it at 258 times the rate. So if money is an important factor to you and you have more than a budget of 32 cents, it would almost always make sense to run it again on the GPU machine.
Can I make a comment there?
Yes.
The thing is, your key space is limited to 36 characters, right? You're just using uppercase and 10 numbers. The ideal key space would be up to 95. So I'm not very sure I agree with this fact that in this particular instance, yes, that's true. But if you try the same instance on LinkedIn, I would probably guess the numbers are going to be inverted. Because LinkedIn does allows all host space, like all character space, so that goes up to 95. So the CPUs are not going to be really helpful when you're trying to brute force even up to like 7 characters on a CPU.
That's true. That's true. And so it really depends on what your hash file looks like, and the password policy and the encryption algorithm. So I agree. It really depends. I found pretty much across my entire career, though, that most organizations, even if they allow you to use special characters and do those kind of things, people follow fairly predictable rules. But it really depends. It could be you work for an organization that requires you to generate a random password using special characters and store it in something like KeyPass or a key escrow, and this may not work as well. So that's a great point. Okay, so I think we're going to have to move through some of this so we can get to the passphrase piece, because I think we only have about 10 more minutes. But what tool set you use and whether you decide to do it yourself or use a CPU or a GPU really depends on what your constraints are. If you're in a situation where your boss comes to you and says, I need you to crack as many passwords as you can to demonstrate to the board of directors by tomorrow that our password policy is too weak to make a case for two-factor authentication, you don't have time to buy hardware and set up a machine. You would probably want to do something like use GPU boxes on Amazon EC2. I should mention, per account, you can only set up 2 of those. If you want more than 2, you actually have to make a special request to them. It's not hard to do, though. Anything on it? Okay, but you can actually save money. If time is not your constraint, you can use spot instances. And so Amazon may have available extra capacity. It's probably hard to tell on the screen, but the same machine that cost us $2.10 per hour currently has a spot price of 34.5 cents per hour. You can bid an amount. You probably want to bid an amount more than that. Specify the total number of servers that you want. And if you don't mind maybe tomorrow not getting any servers, the next day you get some, you can utilize this and you can automate it so that you pass hashes and rule sets to different machines, and then you have more nodes to perform the attack against. It saves you a lot of money if you're able to do this. It's not going to work in every case. It really depends on what your needs are from a business perspective. Okay. In terms of splitting the workload across the servers, the best way to do that we found, and if anyone has a different perspective, definitely chime in, is to break it down by rule set. So for example, if you wanted to try every string that began with an uppercase letter followed by 7 numerics, you could send to one server all the rule sets that begin with a capital A, another one, all the rule sets begin with a B, and you could have 20, it's not the only way you can divide, you could have 26 machines dividing the work and reporting into a central machine. The work will get done in 1/26 of the time. If you have it all being sent to a central machine that keeps track of what hashes have been cracked, you can also reduce the time load because you can tell those child servers that they don't need to continue to try to crack certain hashes that are being cracked by a different machine. 5 minutes. Okay. Why don't you talk about this attack that you did and the splitting of the... Oh, actually, these numbers aren't right, so never mind. The gist of this is the best way to split the attack is not by splitting up the hash file, it's by splitting up the rule sets. Has anyone found different results than that from your password cracking? Okay. Ignore these numbers. These numbers are not right. They were placeholders. Okay. So we talked a little bit about building dictionaries. Bigger dictionaries are not necessarily better. But what we have not found is passphrase dictionaries. Has anyone ever come across a passphrase dictionary? Okay. So we did some work to see if we could build a passphrase dictionary, and this is an XKCD cartoon. The gist of it is they're saying it's harder to crack a passphrase than it is a password, and it's easier to remember. It's I disagree with it a little bit in panel 5 because they're making an assumption that the attacker doesn't know that the user was using 4 words. If you know the organization recommends that their users construct passphrases consisting of 4 words, it's a whole lot easier because...
Or combination dictionary attack would work.
Right. I mean, though there are hundreds of thousands of words in any given language, the average person has a vocabulary of, say, around 10,000 base words. So a base word might be like run, running, runs, but they don't use them every day. So you don't have a pool of 10,000 words in your head generally if you were going to create a passphrase that you would utilize. So you can use that information that you know about human behavior, that if you wanted to string words together, it's not as difficult as just brute force attacking a 20-string phrase. This is information from an article that a study that was done recently. They actually used Amazon's Mechanical Turk to have people create passphrases and measure which was more secure, the 16-character long passphrases or the passwords. If you want to read more about it, you can follow that bit.ly link if you believe in following shortened URLs.
We switched to passphrases too at UTSA.
Yeah, so for about a year when I was at UTSA, I was advocating moving from an 8-character complex password that people were writing down to a 15-character string that had less of a complexity requirement. In fact, completely removed the complexity requirement. Took a year to get buy-in, and we eventually moved to it. And here's some statistics from the historical frequency by password length. We didn't reveal all the information. So anyone want to take a guess at what the longest passphrase that somebody's using at UTSA is? 127 was the max because it was an AD limitation. No guesses. So someone that had a 115-character passphrase, and there are about 15 that had passphrases over 50 characters. So that includes students, faculty, staff, volunteers.
There was I saw a guy the other day had 50, I think it was like 51, 52, and he was typing it in every time.
But we found that most users were resistant when we told them we were moving to 15 characters. When we explained how easy it was to create them, they actually embraced the idea. Okay, so passphrases are really sentences or word combinations. They also can be acronyms, like the first letter of each word in a sentence. Going to move through some of this. But how do you get passphrases? I could ask you what your passphrase is, you could tell me, and I could build up a list. I could beg some organizations to share their passphrases. I know UTSA, that I no longer work for, has a passphrase database now, so maybe Randy can give me some passphrase hashes for me to work on. But there's not really a lot of passphrases out there. And even with the leaked password files that I found, there just aren't a lot of passphrases in there. So how do we go about building a passphrase dictionary? So what we attempted to do is we looked at some various sources like ebooks, movie scripts, song lyrics, tweets, and essentially looked for sentences and looked for some commonality to build up some passphrases. These are some of the components of the software that I wrote. We don't really have time to go through all the details. Essentially, the dictator tells the miner what files to acquire. A hash is created to make sure that we're not pulling, that if we're making sure the files are unique. We don't want to process a file we've already processed. The hoarder adds the files to the queue. Files are pulled out of the queue. They're converted to plain text. They're then converted to lowercase because you can perform transformations using all these tools later on. So we didn't really care whether there were uppercase letters in there. And then the splitter splits the strings apart by sentence by looking for punctuation and records this information to a database I don't have the schema here, but there's a couple of different ways that it's being looked at. One is kind of a easy method that's just looking at each sentence. Another is looking for adjacent words. So if a sentence is, I love to eat apples, the easy way is just to use that as a string, and then also to convert that into an acronym, ILTEA, right? But you could also pull apart parts of that to create phrases. Take the first 2 words, take the first 3 words, and if you pull from enough sources, you start to notice some commonality. Now, that can be used to build a passphrase dictionary, and I don't have one available to release yet, but sometime in the next few weeks, we're going to be releasing a passphrase dictionary and making it available the front end part of the tool so people can build their own. The challenge with this is with building password dictionaries, it's easy to test them against other data sets, but we don't have any good passphrase data sets to test against. So though we can find that some passphrases are fairly common because they get tweeted a lot or used in Facebook status updates, or they're phrases that are in the Bible that people use all over the place, we don't know that they're actually being used as passphrases in organizations where people use those. So if any of you happen to have any passphrase databases or know organizations we could talk to, we'd love to collaborate with them to figure out if this technique would actually be valuable. Any questions about the passphrase? And I'm sorry we had to kind of run through that pretty quickly. Any questions about the passphrase generation piece? Yes?
If passphrases are non-grammatical, so they're just a string of words that they're not a grammatically correct sentence, would that defeat the methodology?
So the methodology doesn't actually look at that. Now down the road, it would be nice to look at the whether it's a verb or a noun and kind of string it together that way. It doesn't care, it's just looking to see if there's punctuation. Now you might encounter some data files where there is no punctuation. It could be like a poem. So you can also look at splitting based on new lines, but no. So if it's just a string that consists of all nouns and it appears enough in enough of the data sources, it counts how many times that appears. Now, you have to be careful. If it appears a lot of times, let's say in tweets, that might be something somebody might use as a passphrase, but if it appears 1,000 times on the same website, it might just be their disclaimer at the bottom of the website. So it really needs to be tweaked to adjust for that, and that hasn't been done yet. And the coding that's being used is not very efficient either at this point. Okay.
Any other questions?
So yes.
Actually, on the last takeaway, is there a good source for actually finding out where these third-party breaches are dumping passwords onto the internet? Or is it just sort of randomly come across them?
So some of them get posted to sites like Skull Security. I monitor Twitter pretty regularly and have some colleagues that are building up databases of these, so I just really work my network to get those. There are people that are mining Pastebin for dumps.
What was the first site you mentioned?
Skull Security.
Skull Security. I think it's skullsecurity.org. Is it .org?
That's a good question.
Oh,
There's
Yes.
there's an icon script at GitHub which, yeah, it goes and passes on the Pastebin. So look for password.
Yeah, well,
Oh, Bitcoin.
Like that. You go and continuously look for that and dump some stuff. If it is there, if it finds that, it usually searches for keywords just for like really great. It has some inbuilt logic in it. It looks for like dumps, keywords, which you can try to obtain that. It's pretty easy.
That's good to know. Yeah, a lot of the dumps that are on Pastebin are sometimes very small,
Yeah.
so they may not provide a lot of value. I've also analyzed some of those and found that it appears sometimes that there's an administrator that's creating passwords for their users, so they may all have the same password, or you might not actually learn a lot from them. So it really depends on what the use case is. It really can vary if it's a different country using a different language. It may or may not provide you value based on what your user set is. Yes.
From looking at the passwords that were not successful in cracking, what best practices and password construction would you reinforce from your research?
I would recommend using passphrases. Now, one of the advantages is just by having a long length, most of the attacks that your bad actors are going to perform are going to involve shorter length, so they may never actually test the key space that you'd utilize. Also, it's kind of a trade-off. If you use special characters that do not appear on the keyboard, if the character set allows that, it's unlikely they'll be guessed. The downside is if you're entering it from something like a smartphone, you as a user may not be able to actually enter your password in easily. Does anyone have any specific recommendations in terms of password creation? Or you have a question?
Well, I can think of both. I mean, I have a generator in a tool that I use called password, and then use it as a password. It generates long, complex passwords. Obviously, there's additional risk with using a password manager. And then you can also then, on a mobile device, copy that onto your phone and paste it.
Right.
If you need to. So, not that I like to do a lot of that. That's possible. But I do have a question.
Yes.
Did you generate your own passwords and figure out what the performance deltas were with better algorithms, like SHA-6, SHA-12?
Oh, you measure the difference? We didn't do that because that's actually pretty readily available in terms of the speed differences for those algorithms. I mean, MD5 and SHA were not designed for passwords. They're pretty fast. You want to use an algorithm like bcrypt, which is slower, because it makes it much more difficult. Well, using salting in an algorithm like bcrypt makes it much, much, much more difficult for an attacker to acquire the password. So that's what I would recommend. In many of these cases, they're just completely unsalted passwords. And another tool you can use is KeyPass. It does something similar to what you're talking about with auto generation. Also works on a lot of different platforms like iOS and Android. One of the caveats, though, is there are quite a few websites that will allow you to create a longer password or passphrase than they will allow you to log in with. So if you create it using one of those tools and paste in your 100-character password, sometimes they will allow that, but in the HTML input box when you log in, it will get truncated to something shorter and you will not be able to log in. And you won't know why, because you'll be seeing obfuscated asterisks and you won't be able to tell that your entire password wasn't passed in. So completely outside of what we were talking about, but a bit of a pet peeve that it would be nice if organizations would address. If any of you have any additional questions, we'll be outside if you want to track us down. We also don't mind if you contact us via email or Twitter. Okay. Well, thanks for your time.
Okay.